Hello and welcome back to Physics Safari. My name is Abhishek and in this video lesson I'm going to discuss about the relative motion in one dimension. I believe you guys have seen the previous videos lectures. If not, do watch them and then come back to this video lesson. So what questions we have done in normal one dimensional motion, I'm going to pick quite a few questions from there also, which I'm going to demonstrate with the help of relative motion concept. And I'm going to show you how it becomes easier if we have the relative motion concept good. Now this topic is a bit challenging. The reason being it needs a lot of imaginations. But if you can overcome this challenge and grab this topic properly, learn this topic properly, you're going to be boosting your ranks. Because a lot of the students do not get this right. So I'm going to teach slowly and from the very basics. Do watch all the series of this relative motion, and I believe once you've done that, you will be definitely confident about this topic. So there's going to be situations in which you have to overcome your physical experience, day-to-day experience, when you have to imagine things over here. Let's say, for example, when you walk in, when you travel through trains, you feel the tree side, is going in the opposite direction of the train. But in reality, that does not happen, right? The train moves, not the tree. But you feel that, There are many cases, like when you're traveling in airplane, you feel that the cloud is going backward and you are like stationary. But that's not happening in reality. In reality, okay, fine, the cloud also moves. But when it is compared with the speed of a plane, which is around 700 to 800 km per hour, that's negligible. Still, you feel that cloud is going backward. Also, I don't know how many of you have witnessed that the plane, at the same time, at the same height, going in the opposite direction. A few months back, I was traveling from Bangalore to, I believe, Patna or Howrah maybe. It's not very common to see these kind of situations, but I've seen another plane was crossing our plane in the opposite direction, and it just went like zoom, very fast. So these things could be understood in a very proper manner if we know the relative motion concept properly. All good? So let us start the relative motion, but before that, let me tell you one thing. Let's suppose I'm having one object over here. It is, let's suppose, moving with the velocity a. This is a a. Now, another object, let's suppose if it is here, and it's moving with the velocity vb, let's suppose this is your object v. A person who is watching all these things from the ground reference, from the ground frame. Okay, so before I get into this thing, I believe you guys know that frame is the position from where the observer is observing the thing, right? So that is called frame, and that's called reference frame. We can have inertial and non-inertial. So if a frame is moving or with a constant velocity or it is at rest, that's called inertial frame, and when it is accelerating, then we call this as a non-inertial frame, and we're going to deal with those things in the Newton laws of motion. Anyways, coming back to this one. So let's suppose when this fellow is watching this entire motion, he will find, okay, the body A and the body B are moving. So this is a normal understanding about the motion. This is normal, observation on the motion. Now let us say that if this person A tries to observe this block B, right, when the object A, let's suppose you are here on this object A, if he is trying to observe the motion of B, then this is called relative motion. ये बात समझ में आ गई? I believe it's clear to all of you. So when the observer himself is moving and he is trying to observe another body in motion, then this study is called relative motion. Okay, that's point number one. Now, these might be moving at a constant velocity or with certain amount of acceleration. So we're going to deal with that also one by one. So for now, we have understood that the motion in which multiple bodies are moving and the observer is in one of those moving body, then this kind of motion is called a relative motion. So if you guys want to make a note of it, please do make a note of this one, that when the observer is sitting in a frame which is moving itself, then this observation is called a relative motion. Now, how do we go about this? थोड़ा समझते हैं. Let's have a little bit of more understanding about this. Now, let's say, let me just take the same example of plane. When you are sitting in a plane and you feel the crowd is moving backward, you assume or you imagine yourselves to be at rest. You will not find yourself in motion. You will feel that okay, you are sitting at rest and rest, everything else is moving around you. So the first point is, in the relative motion studies, the observer imagines himself to be the rest. So the first point is, point number 1, observer imagine to himself or herself, whatever it is, himself to be at rest. Okay, that's one thing. Now let's, for example, over here, if this observer A find himself at rest, then definitely that could be done if I superimpose one more velocity equal and opposite to this velocity VA. If I do that, then these two velocity will get nullified and this object A would come to the rest, imaginary rest, though it's not rest in reality with respect to ground. Okay, so basically what's happening over here? Now let us say this observer in body A is observing B. So we write velocity of B with respect to A should be equals to how much? First of all, this fellow will observe the velocity of B. And since it is at rest, which is because of minus VA, so let's put it here. And this gives you one of the important formulae of the relative motion. A very, very important formula. A very important relation you can say. Now, this is called as, everyone make a note of this one. This is called as velocity of B with respect to A. This is what it means, velocity of B with respect to A. It means A is the observer over here. This entire motion is being observed by the object A. So A is the observer and he is understanding or he is observing the velocity of B. Now this VB is all about velocity of B with respect to ground. This is the velocity with respect to ground. So his velocity is with respect to ground. All good? Now this VA is velocity with respect to ground. So when I say VA, VB or VC, it's all about the velocity of that particular object with respect to ground. They are not the relative velocity. Now we say that that's an absolute velocity. Well, there's nothing absolute. We find ourselves being on Earth at at absolute rest. Well, that again is not absolute. Motion itself is a relative term which I had discussed in the first or second video. Motion cannot be absolute. Now if you look at on the Earth, if you look at to the Earth from space, we find that Earth is moving, right? So the Earth is not also, it's not the absolute motion. But for our easiness in the calculations, we assume that the motion with respect to Earth is the absolute motion. That's what we assume for the easy calculations. All good? So one thing we have understood that VBA is all about velocity of B with respect to A, where VB and VA are the velocities of B and A respectively with respect to the ground. Okay, now going further, if I differentiate it, that would give you what? Acceleration of AB with respect to A. That should be given as acceleration of B minus acceleration of A. Also, if I want to look at the positions, then the position of B with respect to A could also be given as position of B minus the position of A. These are the three fundamental and most important relations in this topic. If you guys can understand this, I believe you will be able to understand the rest of the topic. तो उसको दिमाग में रखो and हमारा काम हो जाएगा. Okay, so let's see one situation. Let's say you are moving in a train. You are moving in a train and the train is moving at a speed velocity of, let's suppose, VA. It is moving with a velocity of VA. Let's say there is one tree. You will look at this tree. Let's suppose this is tree. And you definitely will find that tree is moving in the backward direction. You will feel that way. The train is moving in the backward direction. Let us see mathematically what exactly happens over there. What exactly happens? So the velocity of tree with respect to train, so let's suppose small t, that should be how much? That should be velocity of train minus velocity of the tree. Velocity of train is how much? Let's suppose if it is moving in this direction. So you can say negative v. In reality, velocity of tree with respect to ground is how much? 0. So the velocity of tree with respect to train is going to be how much? Velocity of train with respect to tree with respect to train is going to be negative of v. Negative of v is nothing but the velocity of train. Let's suppose this is velocity of train. Small t. This is the velocity of the, okay, I think I've messed out with the t and t. Okay, so this is like small t. Okay, let's make it a bus, let's make it a bus. You're moving in the bus with the velocity v. So velocity of the tree with respect to bus should be velocity of tree minus velocity of the bus. So velocity of tree is how much? 0 with respect to ground. Velocity of the bus is how much? Negative v. So negative of negative v, well, that's going to give you how much? V. So this train would appear to you to be moving in the right side direction, reason being it's positive, with a velocity of v, which is nothing but equals to the velocity of the bus. So the idea is very clear. When you observe another body, even though that is at rest, from a frame which is moving, then you will find that that particular object is moving in the opposite direction with the same velocity but different direction. I mean, the magnitude should be same and the direction is going to be opposite. So that is the fundamental concept of relative motion. Now, in the relative motion, my dear, if you talk about one dimension, we'll have two kind of questions. One is going to be on the horizontal plane, as in the one track is running, one train is chasing, the thief is running, the cop is chasing. That's one kind of question. Also, from the cars are racing with a different acceleration, different velocities. One is going to catch, we're going to find the minimum distance, maximum distance and stuff like that. And the another one is going to be in the vertical motion. Two, object is being thrown, one is dropping, they're going to meet. Let's suppose there's a balloon which is going up, something is being dropped from there, there's a lift problem. So these are the two fundamental types of questions in the motion in one dimension, in the case of relative motion. Today in this video lesson, I'm going to try and cover up these. If I could not do in the given time, I'm going to make one more video to demonstrate those. Now the idea is very simple. In this topic, we have to deal with more and more numericals to get a better hang of this topic, because there is not much of the concept, as I've told you before also. Only these many things we have and a bit of your imaginations and things will be done. But for that, we need a good amount of practice. So chalo, let's start doing some of the cases, some of the numericals. Before that, let me just clean this. I'm going to start the motion in the horizontal direction, and then I'm going to take you towards the vertical direction motion, and we're going to see nice questions up there. Okay, so here we have. Now, let's start with a very simple question. Let's say that, number one, if I have one body, one car, let's say, it's moving in the horizontal direction with, let's suppose, velocity maybe 7 meters per second. Okay, and I'm assuming that acceleration is 0. There is no acceleration as of now. Another body, let's suppose, at a certain distance is moving at maybe 4 meters per second, and of course acceleration for this also I'm keeping at 0. Now let's suppose the distance between them is 30 meters. Now, will A be able to catch B? Let's suppose this is your car A, this is your car B. And the question is, will A catch B or not? If yes, then in how much time A will be able to catch B? That is my question number one. It's very simple. You can pause the video and get it done. बहुत simple है, not a big deal. So I believe you have paused the video and given it a try. चलो so करते हैं. Let's do it. It's an easy one. Again, we can go with the normal method, like the distance will be same and stuff like that. Now, what I want to do with the relative motion. So, rule number one of the relative motion. Always get yourself on one of the moving object and then observe the another moving object. हमेशा अपने आप को किसी एक moving body पे बैठा लो and then observe the another moving object. That should be the way. Now, if I look at this one, let me make myself seated on this car A. Now what happens over here, I'm going to find velocity of B with respect to A. The reason being, observer is now sitting on the car A. So he's going to observe B. Okay. So the velocity of B with respect to A should be velocity of B minus velocity of A. What is velocity of B? 4 meter per second towards right, so positive. A is how much? 7 meter per second. So this is going to give you how much? Minus 3 meter per second. That's the velocity of B with respect to A. Now my friends, let me tell you one thing. What do you understand by this? VBA as minus 3 meter per second. Now, if I'm looking from this object, this car A, I myself find myself to be at rest. I would find myself to be at rest. I would not be moving, isn't it? I would only see that there is only one object B which is moving. Now, if I look at from this frame, this will not appear to me moving at 4 meter per second towards right anymore. Nahi. Now, how would it appear to me? That's the point. Just grasp this concept. Easy though, but it is gonna get more complicated when we have multiple bodies with the multiple situation. So I want to get you guys right, the basics right from here itself. If I'm on this object A, for me, I would feel that this object B is moving at a velocity of minus 3 meter per second. Well, the minus means towards the left. So if I'm the observer sitting on this car A, for me, I would feel that this object B is moving in this direction at a velocity of 3 meter per second. I believe you guys are okay with this. Now, this is a situation for me. Now, this is no more a relative motion concept, relative motion question. It becomes a simple normal question of motion, where a body is moving at a velocity of 3 meter per second with zero acceleration, and it is approaching me. I just need to understand, I just need to find how much time will it take to reach out to me. Simple si baat hai na ji? So, S could be how much? Ut plus half at square. Here the acceleration is 0, so this part becomes 0. So, you can say that T should be equals to the displacement or distance between them over the, velocity. This velocity, U. What is this value of this velocity? 3 meter per second. So, that implies time should be 30 upon 3, and that's going to give you how much? 10 seconds. So, in 10 seconds, A would be able to catch B bus. Yahi hai ji. So, what exactly have we done? We have converted a relative motion situation to a single body moving, and then we applied the fundamental concept of velocity and displacement relation using the formula this one. Clear hai na? Chalo, ek aur karte hain. Let's do one more question. Let's say second question where I'm gonna introduce the acceleration also. Let's suppose that I have this object and this is moving at velocity of, let's suppose, 5 meter per second, or thoda kam kar lete hain. Let's say 2 meter per second. What the hell, this is shaking. Okay, fair enough. Now, and its acceleration is, let's suppose, maybe 8 meter per second square. Okay. At certain distance, I have another object which is moving at, let's suppose, higher velocity 10 meter per second, but acceleration, okay, just being, let's say, 2 meter per second square. The acceleration over here for this body is very less, which is 2 meter per second square. Let's suppose the initial distance between them is 40 meter. Okay, let's suppose that is 40 meter. All good. Now, what's happening? The question is, will A be able to catch B or not? My question is, will A be able to catch B or not? If yes, in how much time A will be able to catch B? Now, again, it's a question of relative motion. The reason being, two bodies are in motion. So, as per the rules that we have just discussed, make yourself seated on one of the object, either A or B. Try karoge? Chalo. Give it a try. Pause the video. And then once you're done, you can unpause the video and we will do it together. हम लोग साथ में इसको करेंगे जी, है ना? बढ़िया. चलिए. So I believe you guys have already given it a try. Let's do it now. Okay, let me sit on this object car A or whatever it is. So this becomes observer and this becomes object. So the velocity of B with respect to A, that should be how much? Velocity of B minus velocity of A, and that is equals to 10 towards right minus 2 towards right. This is going to be 8 meter per second. That's a point number 1. That is the velocity of B with respect to A. दूसरी बात देखते हैं acceleration of B with respect to A. That's going to be how much? 2 towards right and 8 towards right. So that is going to be negative 6 meter per second square. Kahani feels same hai, the same whole story. The only thing is now what we have is the acceleration. Abhi hamare paas acceleration bhi hai. We have the accelerations as well. So now this entire thing would appear to you as if this is an stationary object. It's a stationary object over here, and this object B is approaching, not approaching, it's 8 meter per second. So basically another object is here, and it is moving with an initial velocity of 8 meter per second with an acceleration of minus 6 meter per second. So acceleration over here is acting in this direction. And this is at rest. It's not moving. It's at rest. It's not moving. So what's going to happen? Since the velocity and the accelerations are in opposite direction, so it will go and then it will come back. As simple as that. It will go forward and it will come back, because here it is going to come at rest. Momentary rest will be here. Velocity is going to be 0, but at the same time acceleration would be acting in this direction only. So this block is definitely going to come back. If I look at the net displacement, that is how much? How much is 40? So this body B has moved 40 meter towards left when A is going to catch B. That's how they're going to catch, right? When A is catching B, then displacement between them should be 0. To let it happen that B should be backward with a 40 meter. B should come back in backward direction with the 40 meters. So net displacement for B, I would say what? Displacement of B is how much? Negative 40 meter. Let us apply the formula. So S is equals to how much? Ut plus half AT square. We all know that. Now S is how much? Negative 40. U is how much? Positive 8. T, no idea. That's okay. Half A is how much? Negative 6. T square. So this is going to give you a quadratic equation. And we're going to solve it. We're going to get the answer, my dear. So this is going to be how much? 40 equals to 8t negative 3t square. So that should be 3t square negative 8t negative 4t, and that should be 0. Well, it looks like a weird quadratic equation. So don't worry. We're going to use the concept of quadratic and we're going to solve it. So the value of t should be how much? The value of t should be minus of b, which is positive 8, plus minus b square, which is 64, minus 4ac. So 40 times 3 is 120 already, times 4 is 480, minus minus plus 480. Now that's going to be the root, and here we have 2 times of a, which is 2 times of 3, that is 6. Whatever it comes should be the right answer. All good? Whatever it comes should be the right answer. देख लो इसको. So it should be how much? 8 plus should be 4, 544. That should be upon 6. All good? So yeah, something like that. So it negative part will not choose, because that would give you a negative value of time. Time cannot be negative, right? So to choose the positive part, and whatever you get will be the right answer. Now we are getting this weird number because I've taken this question randomly with random values. If the values are taken properly, you would be getting the the good looking answer over there. Don't worry. ठीक है जी. Now let's erase it and let's move on to the next part. So we have done these 2 questions. Let's do few more questions in the horizontal direction, and then we're going to shift towards the vertical motion. Okay, just a second. I believe you guys are understanding all these questions properly. चलो एक और situation देखते हैं. Let's have one more situation. Okay, now let us see that number 3. ऐसा करते हैं. Let's have one car over here, at starting from the rest and moving with the acceleration of, let's suppose, 1 meter per second square. Now, at the same time, this one scooter which had an initial velocity of 10 meter per second. This is a scooter, but zero acceleration. So this is about time t is equals to 0. At time t is equals to 0, this is the situation at t is equals to 0 second. So scooter came and just zoomed away at velocity of 10 meter per second. At that time, the car had initial velocity of 0, but it had some acceleration 1 meter per second square. But no matter whatever is the acceleration, if it is starting from rest, another body which is moving at 10 meter per second would definitely go ahead of it. वो निकल जाएगा जी, कोई दिक्कत उसमें नहीं है. That would definitely go ahead. But it has acceleration, so definitely it is going to speed up. It's gonna speed up, and there would be a time when this would be able to catch this scooter, because the velocity of the car would keep on increasing. So there's going to be some time when that would be able to catch the scooter. So question number 1 for you is time. Find the time when car will catch the scooter. Car will catch the scooter. वो उसको पकड़ लेगा जी. That's the point number 1. है ना? तो चलो, let us first do that, and then we'll come back to this. Well, the question is quite a simple thing. Let's suppose the car manages to catch the scooter at, let's suppose, this point. कहीं भी वो catch करता है जी. So let's suppose this is car and here is the scooter. So let's suppose car has caught the scooter. At this time, its velocity is going to be 10 meter per second only, but this will have some velocity v, which I have no idea, but acceleration is going to be, of course, 1 meter per second square. Again, one more thing is common between these two is that they would move the equal amount of distance. Distance moved would be same. Equal distance moved or traveled, whatever you want to say. That's the key idea. That's the trick over there. The distance would be the same by moved by both the bodies. वो बराबर होगा जी. तो फिर लगा लो, कर लेते हैं ना. Let's do it then. So distance moved is same. So let's suppose that car catches the scooter in t time. Okay. Then distance of the car, that should be how much? Ut plus half at square. U is 0. So it's going to be half. A is how much? A is 1. T square. That should be equal to this one. So it's actually moving at the same sort of velocity, 10 meter per second. So let's suppose 10 times of t. So that would give you how much? T square minus 20t is 0, and take the t common, we'll be having t minus 20 equals to 0. So t should be equals to 20, or t is going to be equals to 0 or 20. Of course, at time t is equals to 0, they were at initial starting point. So this is not going to be the answer. The answer has to be 20 seconds. It means the car will be able to catch the scooter in 20 seconds. Pahla question done. Now the second question is, my dear, of course, when this scooter went past the car, it was moving with a greater speed. So if it was moving at a greater speed, so this will increase the gap from the car initially. So it will increase the gap from the car initially, but slowly and gradually, as the car's velocity increases, it will try to narrow down the gap. It will try to bridge the gap which the scooter has created. And that's going to happen after a certain amount of time. That's not going to happen, initially. So the question to you is, find the maximum distance. Find greatest distance. Find the greatest distance between the car and the scooter. Between the car and scooter. जो आपको वो distance निकालना है, maximum distance, before 20 seconds. Before 20 seconds. That's important. Before 20 seconds, because after 20 seconds, since the car has managed to catch the scooter, the distance of the car will keep on increasing, because now at this point, after this point of time, the car would be having a greater velocity due to its acceleration, and that would keep on going. So the car will be going to infinity, the gap will be infinity. So you have to figure out what would be the maximum distance between the car and the scooter before 20 seconds. 20 seconds से पहले कितना उसका distance होगा जो which is maximum. Okay, as per our principle, pause the video, try it, and then we'll do it together. है ना? बढ़िया. Okay जी, तो I believe that you guys have given it a try. आपने try कर रखा है. अब हम लोग इसको साथ में करते हैं. Let me just have a little amount of water. Okay जी. Now we're gonna do it. अब हम लोग इसको करते हैं. देखो जी. Again, since we have multiple bodies in motion, so the concept of relative motion would be a handy technique over here. If you want to do it in ground frame, that also you can do. चलो मैं वो भी बता देता हूँ, है ना? I will teach you that also. But let me first teach you with the help of ground frame. Okay, one thing is quite clear. देखो, let me sit on this car. मैं कार पे बैठ जाता हूँ जी. So this is the car. And since I'm observing this entire situation from the car, then the velocity of car should be, with respect to me, because I'm an observer, should be 0. Now it's not moving, right? With respect to me, because I'm the observer sitting on this car. This scooter, the scooter, initially it was here only at time t is equals to 0, but it was having some velocity. So let's suppose velocity of the scooter with respect to car should be how much? Velocity of scooter minus the velocity of the car. That should be 10 minus 0. That is going to be 10 meter per second. It's positive. It means it should be having a velocity of 10 meter per second rightward. Fair enough, no problem. Let's talk about the acceleration of the scooter with respect to car. That should be how much? Acceleration of the scooter minus the acceleration of the car. Scooter had 0 acceleration, but the car has an acceleration of 1 meter per second. So that is going to be minus of 1 meter per second square. So the acceleration on this scooter should be 1 meter per second square towards left. And my dear friends, you know that when the velocity and the accelerations are in opposite direction, the body would come to a momentary rest for sure. और कभी न कभी वो रुक के वापस आएगा. It is going to stop and it will come back. Well, that's a ideal thing we already know. So this car the observer on the car would feel that this will go forward, will stop at a certain point and will come backward. वो वापस आएगा. It will start from here, it will go and it will stop and it will come back. है ना? So this is going to be the maximum distance. This is going to be the maximum distance. It went and came back. At this point of time, the velocity of the scooter with respect to the observer in the car should be 0. It will stop, it will come back. So imagine kar lo, if you can imagine this or not. It's just like this body is having some initial velocity towards right, but the acceleration is backward direction. So definitely it will go and come back and it will be here. Why? Because the car is catching the scooter in some time, which is how much? 20 seconds already we have found. देखो logically तो सीधा बोल देंगे 10 seconds it is going to catch because it's going to be symmetric motion, right? You know, we throw object, it comes back with the same velocity. So logically, if you are sitting in the MCQ question type exam, so coming back 10 second, because we know it's 20 second already it's given to you. But anyways, let's continue with this. So now this entire thing became a one-dimensional motion in which only one body is moving and this another body is observing, which is at rest. So भैया velocity at this point is how much? 0 है ना? तो चलो let's do it here. इधर ही कर लेते हैं. So we can apply this. V is equals to U plus AT. Energy. V is how much? 0. U is how much? 10 meter per second. A is how much? 1. Right? T is, I have no idea. Let's suppose T. That tells me that T is going to be 10 seconds. So logically, मैंने बोल दिया है ना, that it's going to be going, it's going to reach here at 10 seconds. But my question was the greatest distance. अपने को चाहिए क्या? Greatest distance. ठीक है ना जी? S is going to be equals to how much? UT plus half AT square. We know this. So U is how much? 10. T is happening at how much time? 10 seconds. It's reaching here at 10 seconds. plus half a is how much? Minus of 1. T square is going to be how much? 10 square, which is 100. Likh do ji. This is going to be how much? 100 minus 50. So that's going to be at 50 meter. Okay. So the maximum distance between the car and the scooter is going to be 50 meter. It's going to be 50 meter. है ना? All good, everyone? Correct इसमें? So what exactly we do? We sit on one of the object and we observe the another object. Once we do that, the motion becomes normally, as we've already seen in the previous cases, and then we do the things properly, applying the equation of motions. As simple as that. है ना जी? चलो एक और क्वेश्चन करते हैं. Let's see one more common question that you guys would be coming across. That a fighter plane or maybe a normal jet plane is flying at a certain velocity, and definitely when it is flying, its engine releases some hot gases, due to which it is propelled in the forward direction. If you are observing this outlet thing of the gas, you will find that at a different velocity. But if the same thing is being observed from the ground frame, you will find things in completely different. एक छोटा सा क्वेश्चन करते हैं जी, let us do one question. Now let's say I have a situation in which I have a flight moving अच्छा हो गया, ठीक है, it's moving in this direction at, let's suppose, speed of 500 kilometer per hour. इतने स्पीड से it is going ahead. So of course it is ejecting hot air in the backward direction. वो हवा इसका jet fuel combustion, everything is coming out of it. In question, if it is given that velocity of, I use the term gas for this one, gas with respect to plane, velocity of the gas with respect to plane is, let's suppose, 1500 kilometer per hour. ऐसा कुछ है ना? Find the velocity of the gas with respect to ground. Find velocity of gas with respect to ground. Ground के frame से जी velocity of gas कितना होगा? चलो everyone give it a try. सब try करो. Pause the video. Give it a try. उसके बाद we gonna do it together. फिर हम लोग साथ में करेंगे जी. Pause the video and give it a shot. Let's see how much concept have you learned, कितना आपने सीखा है ना? बढ़िया, चलिए ट्राई कीजिए. All good. I believe you guys have given it a try already. Now let's do it together. हम लोग इसको साथ में करते हैं जी. Okay, so velocity of the gas with respect to plane should be how much? Velocity of gas minus velocity of the plane. Now velocity of the gas with respect to plane is given as 1500 km per hour. Okay, और इसको speed कर दो जी, because velocity, then we have to write direction also. अभी छोड़ दो, direction we will decide. हम लोग decide करेंगे based on the situation. So let's suppose the flight is moving towards right, and then gas definitely is going to go towards left. ऐसा मत बोलना कि हाँ, I was actually teaching one of the student and he was asking in which direction the gas would go, knowing the direction of flight. So not making fun. It's just like it should be well understood. It's a self tutorial things, self explanatory thing, that if the flight is going in this direction, the gas is definitely going to come in the backward direction. ठीक है जी. तो इसको कितना मान लो? Negative 1500, because it is going in the left hand side. That should be equals to velocity of gas minus velocity of the flight or plane, which is 500 km per hour. So the velocity of gas should be how much? Negative 1500 plus 500. Well, that is going to be 1000 with negative kilometer per hour. It's a negative 1000 kilometer per hour. Now negative sign indicates it's going towards the left. So velocity of the gas is all about negative 1000 kilometer per hour. Very simple question, but a very common question. Simple है, but it's kind of common. You should be knowing this. ये आपको पता होना चाहिए जी, है ना? बढ़िया. Now, having done this, so we have done some 4 questions on the horizontal motion, motion in the horizontal. Now let us move towards the vertical, है ना? हम लोग अब चलेंगे जी थोड़ा वर्टिकल मोशंस के बारे में बात करेंगे. आई बिलीव यू गाइस हैव नोटेड इट डाउन और एल्स पॉज द वीडियो एंड डू नोट इट डाउन. ऑल गुड. नाउ एक सिंपल क्वेश्चन करते हैं. आई बिलीव दिस वीडियो इज गोना गेटिंग लॉन्गर, सो let's do one simple question and the rest we're going to do in the next video. एक छोटा क्वेश्चन करते हैं. Let's suppose I have an object which is thrown down at, let's suppose, 10 meter per second. At the same time, if I throw another object from the ground at 30 meter per second, and let's keep the distance between them as 120 meter. My question to you is, this is number 5. My question to you is, how much time would it take to, for this body to meet? और कितने टाइम पे मीट करेगा? And if it is meeting, at what height from the ground they are going to meet? So the question number 1 is time when they meet, time taken to meet. That's the question. Time taken to meet. And the second part of the question is height at which they're going to meet. Height from the ground where they're going to meet. Where they will meet. They will meet. ऊपर कहाँ जाके वो जी meet करेगा? Let's do it together. No need to pause the video. इसको साथ में करते हैं. I'm going to give you an example where you can try on your own. है ना जी? बढ़िया. Again, we have multiple bodies in motion. So what we're going to do? We're going to take the help of concept of relative motion. Again, same process. किसी पे बैठ जाते हैं. Let's sit on either of these. तो चलो जी. If let's suppose this is A, this is B. कहाँ बैठोगे? I'm gonna sit on B. ऊपर बैठते हैं ना? नीचे बैठते हैं क्या मजा? चलो. Let's sit here. I'm like, you can sit on B also. I'm like A also. It's not that you have to sit only on the body which is coming from the top. मेरी मर्जी मैंने ले लिया, है ना? आप किधर भी ले लो, कोई दिक्कत नहीं है. You will definitely get the answer. इस तार ने तो परेशानी कर रखा है. Okay जी. So let's suppose I'm sitting on A, B. So I'm gonna observe A from the frame of B. So this is not moving anymore. If I've taken that as a frame of reference, that is not going to move. उसका velocity हो गया जी 0. So that should be how much? Velocity of A minus velocity of B. So velocity of A is how much? 30 meter per second upward. So 30 minus velocity of B is how much? 10 meter downward. So that's going to be negative of 10 meter. That's going to be how much? 40 meter per second is going to be velocity of A with respect to B. इतना हो गया है ना? बढ़िया. So one thing we have found. Also, let us find the acceleration of A with respect to B, because I'm observing from B, so that's my frame of reference. That should be how much? Acceleration of A minus acceleration of B. Well, A is how much? Acceleration of A is how much? Of course, the gravitational acceleration, so which is acting downward, so negative of G, minus B, it's also falling under gravity, so negative of G, negative positive, minus A plus A is going to be 0. It's quite logical also, right? Both are falling freely under gravity, so the relative acceleration should also be 0. Because दोनों की दुनिया same ही है, right? It's same for both of these, so the relative acceleration would be 0. ऐसे cases में when we have, but don't do it in every cases when the body is going or coming down with a different acceleration. And when we have a propelling machine, let's suppose a plane, a balloon, or anything else, which is not undergoing a free fall or the motion under gravity, in those cases the gravitational accelerations and accelerations will not be same. In those cases you have to be careful, so don't just go 0 all the time कि सर ने बोला था. नहीं, you have to work on this, and whatever you get should be your acceleration under the consideration. But yes, when both the bodies are under the free fall, well, that's going to be 0. That's not a big deal, you can go with that, है ना? But now, so when I'm observing this A from B, B seems to be at rest, which is of course the observer. So A is moving upward with respect to him at 40 meter per second. So he feels that A is coming towards him at a 40 meter per second, and there is no acceleration at all. So the time taken to travel 120 meter should be how much? 3 seconds. So time after which they are going to meet is 3 seconds. Simple, बहुत simple. If you would have been doing it with the concept of normal motion, it would have taken a good amount of time. But abhi simple kahani, simple solution, just 3 seconds to meet. 3 seconds mein they are going to meet. Now the next part of the question is at what height they're going to meet. Look, time is invariant, right? Time does not depend on the frame. So definitely the bodies must have moved for 3 seconds. In those 3 seconds, let us find the displacement or the height which A is going to cover. You know? So second part of the question, part 2 of the question, height at which they're going to meet. So height moved by body A should be how much? H is equals to ut minus half gt square. Please don't say it is 0. That was the only when I'm observing the A with respect to B from B. Now I'm observing A from the ground frame because it is going at a certain height. So we have to find the height with respect to ground. So that's the reason why I'm observing it from the ground frame. One thing I know, it's time. So if be it in whatever frame you are, be it in a lift, ground, plane or whatever, okay, the time is invariant. Time will not change. Hai na? Time would be same. So ठीक है जी, height should be how much? U, 30 meter upward. Time is 3 minus 1 upon 2, G is 10, T square 9, khatam. 2 times 5, 90 minus 45. So it's going to meet at a height of 45 meter. It means the height above the ground at which they are going to meet is going to be 45 meter. So here this will come down and this is going to go up at a height of 45 meter. They are going to meet. And it's simple, everyone. So it's not difficult when you understand the relative motion concept. Nahi samjhe, if you don't understand, then definitely it's going to be very, very difficult. Acha ji, chalo. Let's do one more. When a body is dropped, I'm sure you guys have noted it down. If not, please pause the video and note this down. Important hai, kar lo. In the next lesson, I'm going to make you do some questions based on the lift and some questions based on the balloons and something. Because this is a very standard question that will be tested. Chalo. Okay, so number 6. Same thing, but this time I'm going to drop a body. So drop kar dete hain ji. So let's suppose this is dropped. So U is 0. Height, and this is thrown up with, let's suppose, 30 meter per second only. This time let's suppose the distance is 60 meter. If I ask you the time to meet, I believe you guys will do it in 5 seconds, right? So let's suppose this is A, this is B. Let's assume, observe this time with respect to A. So A se maan lete hain ji. The velocity of B with respect to A is going to be velocity of B minus velocity of A. B is how much? It's falling, so 0. This is going to go up, so minus 30. So velocity of B with respect to A. So B would be appearing to A as if it is coming down with a velocity of 30 meter per second. And both are under the free fall. So the acceleration of B with respect to A should be how much? 0. है ना? हमने क्विज़र पर लाइन कर रखा है, तो I'm not wasting time doing the same thing again and again. तो भैया टाइम कितना हो जाएगा जी? Time should be how much? जो भी अपना distance है, which is 60 upon जो भी है 30. So that's going to be 2 seconds. In 2 seconds, they are going to meet. Rest you can find the height. जो भी चाहिए आप easily you can do that, है ना? So that's all about the horizontal motion and the relative motion in 1D. There are going to be a lot of questions when we come across the boat rail problems, umbrella man problems. There are variations up there. Shortest distance. There are a good amount of variations. The 2D can also be brought with the help of in the terms of projectile also. 2 bullets being fired, one from the down, one of the cliff. They're gonna crash in between. There are really good questions of JEE advanced level, Olympiad levels. है खतरनाक question. हम लोग करेंगे उसको. We're gonna do that as well. Don't worry. Now I'm gonna stop it here itself. It's again 4:30 a.m. Shit, man. Okay, tomorrow I have to wake up all this office thing and all. Okay, so this is one issue which that's the reason why I'm not able to upload video on the daily basis because of my official works and all. But that's okay. I'm going to try and do my best to upload the videos on daily basis. Okay, so yeah, that's all for the now, guys. Let's catch up tomorrow in the next video lesson. And in that video lesson, I'm going to do some more questions on the relative motion. Okay, ji? So thanks for watching, and also if you like the video, do like, share and subscribe, and also don't forget to press the bell icon so you can get the updates, notifications of all the videos that I post. Okay, so karte hain, and also let your friends know about this class. Take it, ji. Chaliye then, let's see you in the next video. Till then, keep learning and keep studying. Take care. See you in the next video. Bye bye.